So I will present my project for the machine learning specialization. So it's the DTA Predict project. It consists on predicting the affinity between a drug molecule and a target protein. And I chose this specific project because before doing the machine learning specialization, I have a background in industrial pharmacy and in biotechnology research. So I wanted to develop a project that would represent one of the machine learning applications in the biotechnology and pharmaceutical research field. So as I said, the goal is to train a model to be able to predict the affinity between a drug molecule and a target protein. And this has applications for computational drug discovery because this affinity will have an impact on the therapeutic effects. So it is based on the training a model on the Kiba dataset. And the architecture of the model is inspired on the graph DTA architecture with three blocks that I will be describing on the following slides. First, I will show you a demo of the project. So basically, this is the user interface. Here, the user can enter a drug molecule in the SMILE sequence format and enter a protein sequence. So this is the sequence of amino acids composing the protein. And then we can visualize the molecule and also predict the affinity score. So here you can see that the predicted affinity score by the model is 12.35, and you can compare with the other affinity scores from the other drug protein pairs. So going back to the details of the project. So as I said, the model is trained on a specific dataset, which is the kinase inhibitor bioactivity dataset. And here you can see on the dataset that the drug molecules are represented by their SMILE sequences, which are the linear representations of the molecules. And the proteins are represented here by the sequence of amino acid. And then there's a fifth column that contains the affinity score. This is an overview of the steps of the project. So first there's a pre-processing step, which means that we perform an exploratory data analysis and we clean the data. And we have to transform the data into a format that can be fed to the model. So for the SMILE sequences, we have to transform them into molecular graphs. For the protein sequences, we used a pre-trained model to generate embeddings. And then for the second part, it's building the machine learning model, training the model, also doing hyperparameter tuning, which means adjusting the parameters to have the best possible results. And then for the last part is evaluating the model. So we use different metrics, the mean absolute error, the mean squared error. Basically, it's comparing the predicted values of the model to the real measured values. And this gives us the evaluation of the model. So for the technologies that I used, for the backend, I used Python and the Flask framework. The user interface was done with HTML, CSS. I used machine learning models, which are graphical convolutional networks, convolutional neural networks, and MLP blocks, and a pre-trained model to transform the protein sequences into embeddings. I used specific machine learning libraries and specific for drug discovery and biochemistry applications. So the DeepChem library, the RDKit tools for visualization, and TensorFlow Keras for building the model. So this is the architecture. So basically there's 3 blocks. So this is the first block that will perform the drug feature extraction. So learning patterns based on the drug molecules. At first I wanted to use a graphical convolutional network, which is very specific for molecular graphs, but due to computational limitations, I ended up using an MLP, so a block composed of fully connected layers. The second block, the CNN convolutional neural network, it's typically a type of machine learning model used for images classifications, but here we are using it to learn pattern and perform feature extraction on the protein sequences. Then both the representations of the drug molecules and protein sequences are concatenated and fed to a third block, an MLP. So composed of fully connected layers, and this third block is the block that will be able to perform the affinity score prediction. So this is an example of a code snippet from this project. So here on the first part, we built the machine learning model based on the hyperparameters selected during hyperparameter tuning. Then the model is compiled, and for this we have to choose an optimization algorithm. Here is the Adam optimizer, and as I said before, we choose the metrics to evaluate the model. So here the mean absolute error, and then we train the model here for 50 epochs, so 50 training cycles. This is the timeline of the project. I had 4 weeks. The first week was for data pre-processing and transforming the data into a suitable format to feed the model with. Second and third week for building, training, performing the hyperparameter tuning and evaluating the model. And the last week for the final adjustments. So the technical challenges were basically handling different molecular representations from small sequences, molecular graphs, and also transforming the protein sequences and integrating multimodal features with the molecular and protein representations. And the main challenge of this project was the computational limitation, because building and training a model like this is very computationally expensive. So I couldn't do it locally. I had to do everything, the building, training the model on Google Colab. And also integrating it with the user interface was also computationally expensive. For the next steps and features that I want to add on future versions, I want to add on the user interface the possibility to choose many molecules and many proteins and be able to visualize with a heat map the affinities between all of them. And I wanted initially to do a comparative study between different kind of models. So for example, the protein sequence feature extraction block, CNN, replace it with another model, an LSTM, for example, and really compare the results between different architectures, but I couldn't do it due to time constraints. And one of the limitations of this project is that it is based on a very specific data set, specific of a single molecule class. And so it cannot be generalized to all the molecule class. So one of the solutions will be to do data consolidation steps, which means combining different data sets. And also for future versions, I want to explore the possibility to use a generative model, a generative adversarial network to generate drug candidates. So in conclusion, the goal of this project, as I said, is to predict the affinity between a molecule and a target protein, and this has many applications on the computational drug discovery field. For the next steps on the project, I need to improve the model by comparing different type of architectures and comparing the results and adding more visualizations tools to the user interface. Thank you for your attention.
Do you have any questions, please?
So I don't understand the score scale. How do you know the maximum and the minimum score? I thought the visualization is a little bit complicated to understand when we do know. I don't know what you do with that, and just to have a number without unity or percentage.
A number for the affinity score. So on the Kiba data set, before building and training the model, I had to do the exploratory data analysis steps. Yeah. So really exploring the data set and the distribution of scores. And mostly the affinity scores were concentrated between 8 and 14, 15. And then there were a few outliers below 8 and a few outliers higher than 15.
Okay.
Well, I have a very low-level question. How it could be used, like in real-life industry, like more by a laboratory? I don't really know your industry, so I understand you have like a strong past in biological stuff. But how could you explain us, like quickly, how is it integrated in the laboratory chain?
So it's on very early stages on the research and on the research stage. When we want, for example, to develop a new molecule for a new therapeutic indication, and we know the biochemical pathways that we want to influence, so we know the target proteins that we want to bind the molecule to. And we could use this to predict in advance the affinity and compare in advance the affinity between different molecules. And so we know that if a molecule has a higher affinity, we will choose this molecule to have a better therapeutic effect, for example.
Thank you.
It is an actual model for proteins by Google, I think. And j'ai vu qu'il y avait un modèle qui existait par Google qui faisait de la découverte de protéines. Est-ce que ça serait pas intéressant de regarder ce qu'il a pu produire et de l'appliquer à votre modèle pour voir s'il n'existait pas des protéines inconnues qui pourraient vous aider dans votre recherche?
Yes, there are other models that were developed for this kind of task. Some pre-trained transformers. For example, for handling molecules, there's the Cambert transformer. Yes. So yes, there are other ways. Also for the architecture, there are other models that could be replaced on the different blocks. And what I wanted to do initially was really compare different types of model. So the CNN replace it with the LSTM, which will be better to analyze the sequential information of proteins. But at the end, due to time constraints, I only had the time to build one model architecture, but of course there are better ones and probably with better results. Okay.
You partly answered to that, but on the other model you used, you show us on the slide the tools and the models you used. What was your criteria to select it? Is it based on what you found,
Yes.
free access or?
Yes, to build the architecture. I based this, before starting the project, I did a bibliographic research. So I searched basically all the studies and articles that I could find on the DTA, on predicting the drug target affinity. And I based this, I compared the results on 3 articles, so mainly 3 architectures, the deep DTA, the graph DTA, and the deep GLSTM. I put them here on the sources. So here you have a source on one of them, the graph DTA. So I compared the results on the 3 articles, and I chose the architecture based on this.
Thank you.
Thank you.
Hello everyone, my name is Fred Urbani. I'm a software engineer and I'm learning AR/VR in Alberton School from December 2024. Today I will introduce you my project Escape Station. This game is take place on a platform in middle of a lake surrounded by mountains. The best for me is I show you a small, a short video to the project. But this is an introduction. This is an animation. During the animation leads the player from a boat to inside of the station. So the station has 2 rooms, separate by a glass door.
For the station is permanently submerged in the lake. Good luck to you, brave visitor.
So the game starts, and there is a top panel with buttons and other information during the game. And the player can teleport himself and grab some object. The first step is to open the glass door to go to the 2 rooms.
The glass door is unlocked.
So you can see the other information about the chessboard. And now the player has to complete the chessboard.
The chess game is complete. The fountain is unlocked.
Okay, he show.
Congratulations. You managed to open the station door before the timer ran out. You may now leave the station. It was a pleasure meeting you, brave visitor.
And now what happened when the player fails? 1 minute before the end of the game, but there is an alarm.
Sorry, brave visitor. You didn't manage to get out of the station in time. We're both going to be submerged in the depths of the lake. It was a pleasure meeting you.
And the last animation, in the last animation, the station is submerged on the lake. Okay, that's all. So this game is built by in Unity engine, and there is a lot of C# scripts. I show you one of them, the script which manage the last animation you see before, and this game is tested only in MetaQuest 3 and 3S, but it's compatible for every type of headset. Donc, so I use OpenXR plugin to have a best compatibility with other headset. And for the move and the teleportation, to grab object and to trigger action, like click on a button, I use XR interactable toolkit. And every object which are grabbable has a XR grab interactable component on it. And I create 2 shaders for the water and the glass door because I wanted to have a special atmosphere, and I built this project for Android, and the water is not very realistic. For accessibility, I use a shader cooler than the original one, because the station is a special asset I take from Alberton School, and I change all shaders. You know the shaders? Okay. And I change the material of every object which are pointed by the laser of the controllers. And for the more visibility, I use a special shader with a white halo. And the text of the different user interface are legible and high contrasted. This is the timeline. I create 2 versions of the game, and the first version is probably used for the introduction animation, because it's the first thing you can see, and I wanted to create a special atmosphere and have as a special animation for it. And I test for the first time the game to my headset. For the second version, I complete the game, and I give the version to another student to have feedback and complete the game. So what success? I'm very happy to complete the animation and create a special atmosphere with sounds, with computer voices, and other music. And the animations of the end is very special, with an alarm that add a lot of stress. And what first? Just one thing, I don't know why, but after 6 minutes, the object in the first room lives by themselves. Sometimes they cross other objects, and I don't know why. But I'm looking forward to fix this problem. And I want to improve the shadow of the water, because at the end it's not very realistic when the station is under the water. Well, it's the editorial, I know. The next step, I want to have more object to move, because it's very limit. And I wanted to use that computer to show something, some help, and display clues. It's probably a good thing. And I wanted to create a Windows platform version using the keyboard and the mouse. In conclusion, I'm very happy to have complete that game. I very enjoy to work on it, and if somebody want to have an immersive experience, I bring my headset if you want. Thank you for your attention. Do you have any question? Thank you.
Okay, I can start. It's a very basic question about the universe you made. Is was something pre-selected as a subject with the school, or you managed to create everything, and the idea comes from your own imagination? And
Good question. No, the station is from Alberton project,
okay.
a small Alberton project, the beginnings of an escape game, and just the first part of the escape game, okay. To open the glass door. And I like this project very, very much, and I decided to complete it, and to take the station from a desert, and I put it on a new terrain, and I submerged the terrain with my shader of water. So it's very different, but in the first project, no music, no computer voice, and no sound. So it's very different.
Okay. Thank you.
Did you make any assets game, 3D assets with Blender, like?
I wanted to create the, pas comment on dit in English, but to climb to the station, yeah, from the boat. I create a
ladder?
Yes, thank you. But the render is very bad, and okay, I have no time to lose to create that. Okay. So I take the main character from Adobe site, yeah, and the station is complete, but I complete the animation inside on it, and I download the boat, but I not create any object by myself.
And you said you want to support Windows platform with keyboard and mouse. How do you translate it from the AR VR world to the keyboard mouse?
Very simply.
Yeah.
That's the same game, but I add some event object to pilot to manage the keyboard and the mouse.
Okay.
But it's the same game, so it's always possible to use an headset and Windows.
Okay.
Small question. When you show the stack you used, like OpenXR plugin, stuff like that, is it like free access tools you can
Yes.
use freely? Okay.
Yes. Yes.
And was there like the prerequis to use that? Or it was like part of the project? Or you choose by yourself what you wanted to use?
The two things, I use all these plugins by myself, but the original project use it also, and I learn by myself to grab objects differently, and to trigger the electric projector. I learn by myself.
Thank you.
You're welcome.
No question.
Thank you.